I've made a lot of animations where people have asked if I've used geometry nodes, and my answer is usually no, because animating things individually with keyframes usually allows for a much more polished result. But in some cases, like with motion graphics where you have a huge number of pieces and they only need fairly simple transformations, we can automate that with geometry nodes. I'm Jonathan Lampel from cgcookie.com, and in this video, I'll show you how to create one of the most essential motion graphics effects using geometry nodes. And you can download the result for free in the link below and use it as a modifier however you'd like. If you're completely new to geometry nodes and find the topic a bit challenging, I have a full introductory course linked in the description called Assemble that walks you through exactly how to get started. The effect we're going to build today is just a transition between two transformations. What makes it so powerful though is that we can offset the animation per item, add easing, arcs to the motion, anticipation, overshoot, and randomization, so you can make a wide variety of complex looking transitions extremely quickly. To get started, let's open Blender and switch to the Geometry Nodes workspace. I'll keep the default cube for once and click New in the Geometry Nodes editor to add a new Geometry Nodes modifier. I'd like to use text as an example of this effect because that's going to be my main use case for it, and there are two ways to create text within Blender. You can either go to the 3D view and hit Shift A and add a text object, or you can add text in Geometry Nodes. I'm going to make this setup support both types of text, but first let's create some text in Geometry Nodes because that's going to be a little bit easier to start out with. So I'll hit Shift A, go down to Utilities and Text, and I'll choose String to Curves, string being the programming name for text. Here in the string input, I'll just type in Geometry Nodes. Then I'll go to Top View in the 3D view, and to fill this in, I'll just use a Fill Curves node, Shift A, Curve, Operations, and Fill Curve. You can change all of the settings on the text in the String to Curves node, but that's a topic for another day. I will change the font though, because the default Blender font is not that fun to look at. Next, let's make this text move. Luckily, when we make text in Geometry Nodes, it gets added as instances. So here we have curve instances, where we can see over in our spreadsheet editor, if we click on instances, we have 15 instances, one for each character, and each instance consists of curves. When we use the Fill Curves node, we still have instances, but now they're converted into mesh instances. The reason instances are so great to work with when it comes to transformations is that they remember their position, rotation, and scale. To move an instance, we just have to go to Shift A, Instances, and Translate Instances. Now I can change the position of my text by changing the translation input. For this effect, we want to have both a start position and an end position, and then blend between them. So to blend between two vectors, or two sets of X, Y, and Z positions, we can drag out from the translation and add a mix node. That will automatically add the mix node as the vector type, and we can have a start position and an end position. So if I start it at 1 along the y-axis, I can change this factor and blend between those two positions. So far so good, but when it comes to animation, if you just go linearly from A to B, then it's kind of a boring animation. Oftentimes, it looks a lot better when something moves in an arc. So let's shift the position a bit when it's in the middle between A and B. To do that, I'm going to add a vector add node and add to the position. I'll drag out from the result and just type in add. I have a whole video about working with vector math in geometry nodes, and I'd really recommend watching that if you're curious. One of the main takeaways though is that adding and subtracting is the same as shifting values around or moving them, whereas multiplication and division is used for scaling. So if I just add a little bit on the x-axis here, then I can shift this over. And I can still use this factor to blend between the top and the bottom, and this value just shifts it over from wherever it was. Now let's plug all of these inputs into the group input here so that we can change them in the modifier itself. I'll set them all to 0, 0, 0 so that the defaults are set that way. I'll plug in A, B, and the second vector for the add node. Then I'll hit N to open up my sidebar, and that way I can edit these inputs. For A, I'll call that the start position. B will be the end position. And the last one will be the middle position. Then I'll drag the middle position up above the end position. I'll also take my factor, set that to 0 for the default, and drag that in as well. I'll leave that called factor and place that above the start position. Now I'll start it at 2 on the y-axis, and for the middle position, I'll shift it over by 0.5. Alright, but now we want the middle position to be only mixed in the middle of this factor, not at 0 or 1, but at 0.5. The way that we can do that is by manipulating the middle position using the factor. So I'll drag out from the middle position, and then I'll use a vector math and multiply node. The reason for this is that when the value is multiplied by 0, it'll equal 0, and when it's multiplied by 1, there will be no change. So if I were to plug this into the vector here, and use the factor as the second value for the multiply, then this will get mixed in more and more as the factor grows. We can also use a scale operation instead, which is the exact same thing, but just uses the same value for the x, y, and z axis. It's just a little bit more simple to use. So now this works, but we want to manipulate the factor such that it's at 100% right at 0.5, and then goes back to 0 right at the end. The easiest way to do that is to use a float curve, which is a good way to visually manipulate values between 0 and 1. So I'll go to Shift-A, down to Utilities, Math, and Float Curve. I'll drag and drop that between the factor and the scale, and the x-axis of the float curve represents the input, and the y-axis represents the output. So you can think of this first value as the input, and this second value as the output. Now, when the input is 0, I also want the output to be 0, so this point is perfect here in the bottom left. But if I choose this one on the top right, when the input is 1, I also want the output to be 0. So I'll type in 0 and hit enter. Now, no matter what the factor is, it'll always equal 0. But then I can left-click and drag to create a new point here at the bottom, and I'll place that at 0.5 exactly, and then set that all the way to 1. So when this factor is 0.5, that gets mixed in with a value of 1. And as a benefit, it creates this nice arc. We'll come back and add some cool little features to this setup in just a bit, but right now let's make it so that each letter drops one by one. For that, we can manipulate the factor before it gets plugged into these inputs. And to organize things a little bit, I'll take the initial text here, move it off to the side, and then I'll take this whole group, Shift-P to create a new frame and parent it to it. Select the frame and then hit F2, and I'll call this location. Oh, and I'll put the translate instances in there as well. And then we're also going to create one of these for the rotation and scale. But for now, just to work on the factor separately, I'll Shift-D on this group input, Alt-P to remove it from the frame, and move it up above the location so we have some room to work. Then I'll plug this factor, the factor for the mix node, and also the float curves node. And maybe add a reroute node by Shift right-click and dragging, just to keep things a little bit cleaner. To offset the animation per instance, we just need to offset the factor per instance. So I'll hit Shift-A, go down to Utilities, go down to Math, and choose a math node. If we add or subtract from the factor, then we'll play through the animation. Now, each instance has a number associated with it called the index, and we can see that in our spreadsheet editor over here on the far left column. We have 15 instances, and they're ordered from 0 to 14. And we can use this index to add to the factor. So I'll just drag out from the second value for the add node and type in index. The first instance is going to stay where it was because it has an index of 0, so nothing gets added, but all the rest are going to snap to the end of the animation because it's expecting a factor between 0 and 1, but instead we're going all the way from 0 to 14. So the rest of these have a value of way above 1. We can still see that it's working though if we go to our location nodes and just choose unclamp factor from this mix node. Now we can see that each instance is indeed offset, but just by way too much. So the first thing that we need to do is take this range that's currently going from 0 to 14 and squish that down to a range of 0 to 1, which is a perfect use of the map range node. So I'll drag out from this add node, type in map range, and plug that in between. The from values represent the input range, which right now is 0 to 14. And then the two values represent the range that we want to squish it down to, which in this case is 0 to 1, which is perfect. So now if we play through our animation, it barely moves, but it is offsetting within that 0 to 1 range. To offset this correctly, we need another map range here at the beginning before the factor gets plugged into the add node. because we're taking a tiny value, like 0.1, 0.2, whatever that is, and adding a whole lot to it, and then squishing that back down into a range of 0 to 1. So this factor is having almost no effect. So what we need to do is to boost that range all the way between 0 and 14. So kind of the opposite of what we did here. So I'll take this map range node and Shift D to duplicate that over. And this time we'll go from a range of 0 to 1 to a range of 0 to 14. Now as we play back the animation, that's looking pretty close. The only thing is that we all want them to start at the starting line, not halfway in between. If you think about the result we're getting right now, it makes sense because the first one has an index of 0, so it's starting at 0, but this last one has an index of 14, so it's starting at 14, which is the end of the animation. So to make the last one start at 0 rather than at 14, I'll set the to minimum here to -14. And with that, now they all start at the beginning and end at the end. This is already looking pretty sweet, and I want to see it played through, so let's add some keyframes. I'll drag up my timeline, and on frame 1, I'll add a keyframe for a factor of 0, and then on frame 50, I'll keyframe a factor of 1. Then I'll set the end of my animation to 75, just so we have some time at the end, and hit spacebar to play through. Okay, that's already pretty satisfying. But if we were to change our text, then this would break, because right now we happen to have 15 instances, and we've hard-coded the values between 0 and 14, but if we have 12 instances or 100, then this isn't going to work. So let's use the count of how many instances we have to drive these values. To find how many instances we have, we can go to Shift-A, up to Attribute, and choose Domain Size. Domain being instances, volumes, point clouds, curves, or meshes. Let's switch this over to instances, and here if we plug in our instance geometry, we can get our instance count. So I'll take my instances and move them all the way over here, and plug the mesh instances into the geometry. Then I can take this instance count and plug this into the to maximum, and also the from maximum on the other node. This is going to give us a close but not quite result. It's going to be slightly off, and that's because we have 15 instances. But the index is going from 0 to 14 because when programmers count, they start at 0. So we just need to subtract 1 from this instance count to get to that value of 14. So I'll take the instance count, drag out, and just choose subtract, and subtract a value of 1. Then I'll plug that into the to maximum for the first map range, and the from maximum for the second. Then I can multiply this value by -1 to get that -14 for the first map range. So I'll move this over again, Shift D, change that to multiply, and multiply by -1. And there we go. Now no matter what we type into the text, it's always going to work. I'll select all of these nodes now, and then hit Ctrl-G to make a new group, because we're going to be doing a lot of work with this factor. So that way we can just keep it a little bit more organized. Oh, and it looks like I accidentally plugged the multiply node into the to maximum. So let's instead take the subtract, plug that into the to maximum, and this one into the to minimum. There we go. And now when we play through our animation, things are looking pretty good. But it is still looking a little bit boring. I do like the arc of the movement in the middle, but if we take that away, then notice how everything moves at a constant rate. That can be great sometimes, but other times we want an ease in or an ease out, or maybe both. So let's add some easing to this factor. The easiest way to do that is with another float curve node. So let's move this group output off to the side, hit Shift-A, go down to Utilities and Math, and choose Float Curve. To make this ease in and ease out, we just need to create a little bit of an S. If we left-click on this line and drag up and out, about near the top, I'll put it in the middle of this box just to the left here, and then for this one, I'll put it in the middle of the box just to the right of the start. So now it's going to start out very gradually, speed up a lot, and then slow down right before the end. Now when we play this back, that motion looks a lot more smooth, but we probably want to have a couple different options for our easing. So here's one of them, but then I'll Ctrl-Shift-D to duplicate this up to create another one while still being connected to the map range, and this one's going to be our ease out. So I'll just take this second point here and click the X to delete it, and then put this one at exactly 0.25, and 0.75. So when the input factor is at 0.25, it's already gone all the way to 0.75, and then the rest of this range smoothly transitions from 0.75 all the way to 1. Now when we play this back, it pops into existence and then slows down. Next, let's invert this for an ease in. Again, Control-Shift-D, and maybe I'll stack these so that it's easy to see them all. And this one will do the opposite. When the input is 0.75, I want the output to be 0.25, so it starts slow and ends fast. Now, there's no reason we can't mess with this as much as we want, so let's actually take this to the extreme and make a bounce effect. I'll take this float curve here, Control-Shift-D to create another duplicate, and plug this one into the result. So this first one, I want it to reach a value of 1 really quickly. So I'll take this second point here and place it all the way at 1. Then I'll create a new point between there and the start and gradually ease into that drop. Then I'll bounce that back up, then back down, and then back up again. This is going to look a little bit wrong because, as our animation instructor Wayne Dixon will happily tell you, things don't slow down before they hit the ground, but that's exactly what's happening here. So we need to take the points that hit 1 and turn them into vector handles, such that they actually speed up before they hit the ground and pop right back. So I'll do that for this one as well. Turn that into a vector handle. And then let's adjust these so that each bounce gets progressively smaller. And it'd be nice to have 3 bounces, so I'll actually add in another one here. Again, turn that into a vector handle and pull up one more bounce, just a small one. And we want the curve of this bounce to roughly follow this shape, with each bounce taking less and less time. So I'll zoom in here really close and make this last one pretty small. Make this next one a bit bigger. I guess I'm going to have to really squish these together to get the correct shape. And if you're really picky about this like me, then you'll notice that this isn't quite an arc, and these points are a little bit hard to deal with as opposed to working in the graph editor. But what we can do is just create a second point near it and kind of round this out a little bit more. All right, so I'll do that there and also there and create these nice arcs. Okay, so let's try this out. Hit space, and that looks pretty good. I'll probably spend way too much time tweaking this for the final version, but for the sake of time in this tutorial, I'll leave it at that. For now, let's let the user in the modifier switch between all of these. Luckily, we have a new node in Blender 4.1 called the menu switch. For some reason, you can't find it in the search menu yet, but you can hit Shift-A, go down to Utilities, and choose Menu Switch. Now in the Node tab of the sidebar, we can go to the Menu Switch node, and let's name all of these. First, let's have an easing option of None, such that it's still linear. Then the second one will be Ease In. The next one will be Ease Out. After that, we have In and Out. And then we also have Bounce. Let's switch this from geometry to float. Plug the output into the result. Plug the first value from the map range into None. Plug the ease in into in, out into out, and so on and so forth. And I'll organize these a little bit and make a frame and call this easing. Then we can take this menu and put it in the input. I'll Shift-D this group input and put it over in this frame, just so I'm not dragging strings all the way across. And over in the group tab, I'll double click on the menu and call this easing. Then I'll hit Control Tab to go out of this group and plug this menu into the group input and drag and drop that right below the factor. Now we can play back our animation and change this in the modifier really easily in real time. All right, now I'll leave this at none because seeing the linear animation while we're working will help us spot any potential issues. Next, I'd like to introduce some anticipation, which is where the character moves a little bit in the opposite direction before getting started. By the way, the reason that we're doing this in geometry nodes rather than the graph editor, we only have the one set of keyframes for the factor to work with. And if we were to do something like our ease in or ease out with the graph editor, here I'll just select everything and hit period on the number pad to expand this view. And by the way, I hit Control Tab to switch from the timeline to the graph editor. If I take this top keyframe and scale it up to ease it out and play this back, then it does ease out, but what it does is it slows down the entire animation at the end, where when we implement it with nodes, we're able to ease out each character individually, not the entire factor. So I'll hit Ctrl-Z and undo that. In fact, we could select everything with A, hit V and change this to vector handles. And now this animation truly is linear, and we can set the easing here instead. Alright, but now we'll hit Ctrl-Tab to switch from the graph editor back to the timeline. Drag that down, and let's add a little bit of anticipation, or movement in the opposite direction. Well, we can do that just in our factor here, which I'll rename this node group as factor. Then I'll hit Tab to enter it, and let's add that after the easing. We can add the anticipation with another float curve node. So I'll drag out from the output and just type in float curve and plug this into the result. What we want to do here is, as the animation gets going, briefly move the factor in the opposite direction or in the negative direction. Well, if we left click and try to place a point here, we actually can't drag it below 0. But that's because the float curve is currently clamped. Now, it's not incredibly obvious, but this icon that's usually used for masking in the float curve is actually used for clipping. So if we choose that and uncheck use clipping, then we can left click and drag on this float curve and move around it outside of the 0 to 1 bounds. That means we can take this point here, and when it's at 0.25, we can actually put it at negative 0.25. So it'll move in the opposite direction and bounce back up. So I'll hit play, and you can see that works perfectly. But I'll go ahead and set this easing to none and play through this again. And you can see that it has a little bit of an ease in, which looks really good, but it's also being applied on top of our existing easing. So it makes intuitive sense to make all of these curves look nice and smooth here in the node editor, but since we're already applying easing here at the beginning, this is going to give us a slightly skewed result. What we can actually do is take this point and just turn it into a vector handle, which looks very harsh, but will work better with our easing. So as I play this back, when the easing is set to none, we'll still get a truly linear animation. But when the easing is set to ease in or ease out, now it's animating properly and that easing isn't being applied twice. Now let's do this exact same thing, but for overshoot at the end of the animation. I'll hit Ctrl-Shift-D on this float curve here and plug this one into the result instead. Now I'll take this point, and when the input is 0.75, I want the result to be 1.25. All the way up there. Now when we play this back, it shoots through the floor a little bit and bounces back up. Now I want to try making these effects a little bit more extreme. Let's just try it and see how it goes. So instead of 1.25, I'll try 1.5 and see if that's too much. Okay, I think we should at least give the user the option of pushing things that far, and then let them dial it back if they want. So for this one, I'll also set the point to negative 0.5, such that it's pretty extreme. And now let's go ahead and mix these together. The problem with just chaining these together is that one is going to kind of cancel the other out. If I play this back, you can see that the anticipation is happening properly, but then the overshoot is happening really fast. So if we have both of these applied, what I'd like to do is smoothly blend between one and the other. We can control how much of these effects are getting applied by adjusting this factor value. If I set these to 0, then nothing's going to happen. And again, I'll set my easing to none, just so that we can see the linear animation. For this first one, I'd like the factor to be 1 all the way from the start, all the way to 0.25. And then it can blend out all the way to 0.75 up here, so that it's 0 by the time this overshoot kicks in. There are a variety of ways that we could do this, but let's do it with a map range node. So I'll take this factor input and choose a map range node. Now when the input value is 0, I'd like the output value to be 1. So I'll set the to minimum, so the from minimum is fine at 0, but then the to minimum I want to be 1. And then the input is 1, I want the output to be 0. So I'll set the to maximum to 0, and that just kind of flips this factor around on its head. But when thinking about the input values, I know I only want the gradient to be from 0.25 to 0.75. So I'll set the from minimum to 0.25. That way anything before that is still going to be 1, and the blend will only start at 0.25. And then I want that blend to end at 0.75 and continue to be 0 after that. So I'll set the from maximum to 0.75. By the way, if you find the map range node a little bit intimidating, I do have a full video explaining exactly how it works with some visual examples that will hopefully help. But now I can plug this into the factor value, and it'll only get applied in that range. Then I can hit Ctrl-Shift-D and move this over. And for the overshoot, when the value is at 0.25, I want the factor to be 0, such that it's 100% still being controlled by the anticipation. And then when it's at 0.75, I want it to be 100% controlled by the overshoot. So I'll set the two maximum to 0.75. Again, just flipping these around. Then I'll plug this result into the factor. And now we have both anticipation and overshoot and a smooth blend in between them. I'd really like the user to be able to control exactly how much this gets added though in the modifier. I'll take a group input here, Shift-D, Alt-P to move it out of that frame. And here I'll just unplug this factor really quick and plug that into the bottom empty input. Then I'll do that one more time just so that we have two inputs, but they're automatically the right type. Now I'll plug that back in, and I'll name this first one Anticipation, and the last one Overshoot. Then we can use these values to multiply what gets plugged into the factor. That way, when the user inputs a value of 1, and we'll get this full effect, but anything less than 1 will reduce the effect, and when the user inputs 0, then this resulting factor will always be 0. So let's take this map range node and drag out, and choose multiply. Then I can multiply by the anticipation, and then I'll Shift-D, duplicate this multiply over, and multiply by the amount of overshoot. Now I'll take all these nodes, Shift-P to make a frame around them, and then Control-Tab to jump out to my modifier here, and plug these into the modifier, anticipation and overshoot. Now would be a good time to start organizing this modifier though, because it's going to get pretty big. Luckily, we now have panels that we can use in geometry nodes, so I'll click the plus button in the interface in the sidebar and add a new panel. This one I'll call the start, and then I'll add two more. The second one I'll call the middle, and the last one I'll call the end. I'll take this start position and move that into the start panel, and likewise with the middle and the end. Then I'll take the anticipation and move that to the start panel, and move the overshoot to the end panel. Now we can easily control this value from the modifier, which is just really fun to mess with. Now that we have these effects, let's take a second look at our location transformation. Because now if we have some anticipation, and we have a middle position, such that it moves in an arc, then it looks pretty good, but it's not really anticipating in the right way. See, things look a little bit awkward. Things start out moving straight up, and then pop outwards, and come back down. The reason for that is that the output of this float curve is currently clamped between 0 and 1. It's not allowing the middle value to be interpolated in the negative direction. So all we need to do is click this little mask icon and uncheck Use Clipping. Now it's not going to update right away for whatever reason, but if you adjust this factor a little bit, then you can see something strange happen. It'll pop way in the opposite direction, which does look kind of cool, but it also might not be what you want. This is a bit of an inherent limitation with this rounded interpolation though, because if we look at the negative values, you can see that the slope is really, really steep. And as we get into these negative values, we start getting very negative very quickly. So we could try to smooth this out here at the end, but that's going to end up looking super weird. Now you can't add points outside of 0 to 1 for whatever reason, but I can create a point inside and then drag it back outside. So I could go ahead and make a curve like this, such that it doesn't go as crazy, but then we're not going to get this smooth arc like we had before. Things are going to look a little bit weird. We're not going to get that perfect arc, and we could try to recreate that perfect arc by making points like that, but then we're just going to have that sharp transition between here and here, and again, we're not going to be anticipating in the right direction. So I've kind of chalked this up to an unsolvable problem, but we can let the user choose between different types of interpolation based on what they want for their animation. So for this first one, I'll go ahead and remove these extra points. And again, you can't add or delete points outside of the 0 to 1 range, so I'll drag it in that range first, and just delete it. And this is going to be our first type of interpolation. I'll hit Control-Shift-D and duplicate this upwards. And this one I'll have be linear. So I'll take this top point and just turn that into a vector handle. And that way, as it goes outside of that 0 to 1 range, we get a much more gradual slope. So let's plug this into the scale value instead, and we get a much more reasonable anticipation. What's cool about doing it this way, though, is that the anticipation is in the correct direction. It moves in the opposite direction of the arc of the movement. Now, I'd really like it to move in an actual arc. I tried to make it so that it could go, all the way around before it continues down that way, but that turns out to be a pretty difficult problem, so I'll leave that for another day. Now let's add one more type of interpolation that's kind of a mix between the two. I'll take the round one, Control-Shift-D, and duplicate that up, plug that in, and this one's going to be a little bit smoother at the top, but it'll become more gradual towards the end. So I'll create a point inside and then drag that outside of the 0 to 1 range, and put that all the way down here at about -0.5 and -0.5. Then I'll do the same thing on this side. Create a point inside the range and drag it outwards. It's kind of just like a weird little hack. And now we have something that's kind of smoothed, but isn't as extreme outside of the 0 to 1 range. So it works well with anticipation and overshoot, but the arc of the movement isn't quite as nice. You can see it looks a little bit floaty there at the beginning and the end. But in some cases, this can still be a good option. So just like before, let's go ahead and create a group here, because we're going to want to use this with the location, rotation, and the scale, and let the user choose from the modifier which type of interpolation to use. So I'll take all three of these, and that reroute, and hit Control-G to create a new group. Then I'll create another switch to switch between these, but unfortunately we can't use a menu switch here. Even though that would be the most useful here, for whatever reason, if you have multiple groups using the same menu switch, you can't drive that from the modifier. So I think that's just a limitation that will be fixed eventually, but for now, let's use an index switch. So Shift-A, Utilities, and Index switch, which is basically the same thing, but you're inputting an index rather than a menu. So let's plug this one into 0, this one into 1. Oh, we need to switch this to float. And then in the index switch, in the node tab of the sidebar, let's click Add Item and plug this into 2 and output the result. Then I'll take this index and plug that into the group input. And in the group tab, I'll name that Interpolation. Then I'll hit Control Tab, rename the group to Middle Interpolation. And here we can create a menu switch inside the modifier itself and then just plug that in to the index switch. So Shift-A, Utilities, and Menu switch. Switch this from geometry to integer. Over in the node tab, the first one I'll call linear. The second one I'll call smooth. And the third one I'll call round. Linear I'll leave at 0. Smooth I'll set to 1, and round I'll set to 2. Again, this is just a hack to get around the menu switch limitation. Plug that output into the interpolation, and plug the menu into the modifier. Over in the group tab, I'll rename this menu to Interpolation, and drag that into the middle panel. Okay, the last thing that I want to do for our location here is add a bit of randomization, because that can look super cool. So let's take our positions and randomize them a little bit. We can do that by adding in a random value, again because adding is shifting. So I'll take my start position here, search for add, and then plug this in as A. Then for the second vector, we can use a random value node. It's nice to add it via search, that way it automatically pops in as a vector type. And let's add this maximum to our modifier input. I'll call this one start location. And if I called it random start location and put it in the start panel, after we add the rotation and scale for all of these, then this panels will just be too huge. So what I'll do is just add a new panel and call this randomization or randomize. Put that all the way at the end because it'll probably be less used, and put the start location in there. Also, if I called it random start location, the name would just be too long and it would get cut off in the modifier. So I'll call that good enough. And then I'll take the vector for that and just flip it for the minimum here, because otherwise things would just get offset a little bit too much here at the beginning. But I can center this around 0, just by taking this and scaling it, or multiplying all three values at the same time by -1. Plug that in, and there we go. So now we can use this to jumble up the letters, which is pretty sweet. But I want the default to be 0, 0, 0, so I'll choose this in the modifier and set this to 0. I'll also set the subtype to these vectors as translation. Same thing for these as well, just so that they show up with units, which is pretty nice. Okay, now I also want to do this for the middle and end positions, and so that it doesn't take up so much space, I'll just take all these three, hit Ctrl G, and let's also add an input for the seed, just so we can choose how it gets randomized, and then Ctrl Tab to go out of that group, and I'll call this randomized location. All right, then I'll plug the seed into the group input and put that in the randomize panel. Okay, then I can Shift D, duplicate this over, and also put this in the middle position. Shift D one more time and drop that on the connection for the end position. I'll plug the same seed into all three and set these values to 0, 0, 0 and plug them into the group input as well. This first one will be middle location, and the last one will be end location. Again, setting the subtype to translation. Okay, pretty sweet. Now it can start somewhere random and move into place. All right, now let's kind of zero everything out here just to make sure that we're all moving correctly. Okay, and if we take out the anticipation, let's say maybe randomize the middle value just to make sure this all works. Okay, cool. With that, we're ready to move on to rotation and scale, which are going to be pretty quick because it's almost exactly this same setup. I'll go ahead and organize this just a little bit by taking these nodes and just kind of shifting them over. Okay, I'll move my group output way off to the side and Control Shift D, duplicate them over. I'll go ahead and cut the geometry lines though by Control right click and dragging. And instead of translating instances, this time we want to rotate them. So I'll type in rotate instances and put that over here instead and delete that translate instances node. If you look carefully on this rotate instances node, we have this rotation socket, which is different than the vector socket, even though on the surface, it's still a set of 3 numbers. So we could drive rotations with vectors just like we've done in previous videos, but we may as well get used to using the new rotation socket, and that way we don't have to worry about quaternions or radians or anything like that. So let's just switch everything over to the rotation socket. First, let's do that for our mix nodes here. Let's switch it from vector to rotation. Then, since we're not working with vectors anymore, I'll get rid of these vector math nodes. And let's change these randomized nodes to rotations as well. So I'll click the number icon next to the data block. That way I'll make it a single user, and editing it won't edit the randomized location nodes that we just created. So I'll change this to randomize rotation. And I'll select that on these group nodes as well. Randomize rotation and randomize rotation. Then I'll hit Tab and change the input type to rotation and the output type to rotation as well. But instead of adding, what we're going to do is take the existing rotation and rotate it by just a little bit more. But instead of adding vectors, what we can do is take the rotation that's coming from the rotation socket and rotate it by a little bit more. So I'll type in rotate and choose rotate rotation, which might sound confusing, but again, you're just taking an existing rotation and rotating it by some amount more. Then I'll take this rotation and plug it into the output, and I'll call both of these rotation. And for this random value, we actually don't get a rotation output option, but that's okay. We can plug this directly into the rotate by, and that'll work just fine. If you want, you could convert from vector to rotation by choosing Euler to rotation. That way all your sockets match, but it's going to do that under the hood anyway, so you don't need to worry about it. Then I'll hit Control Tab, and let's plug the start rotation over into the first value of the mix node, and the end rotation into socket B for the mix node. Then I'll disconnect these inputs here because we don't want the location information being plugged in, and instead we can plug these in as new inputs for our modifier. I'll plug all 3 of them into the empty socket here at the bottom, and I'll call the first one start rotation, the middle one middle, and the last one end. I'll also sort them into the start, middle, and end panels. One thing that you might notice is that this line between the interpolation and the menu switch is red, which indicates an error. That's because, like I mentioned before, the same input for the menu switch can't be plugged into 2 menus, and we have one over here and one over here. So the thing that we can do is just reroute this guy all the way over here. I'll plug in a reroute and go ahead and use this instead, which is the whole reason why we used an integer switch. So I'll go ahead and get rid of the menu switch and move this reroute over, and that works just fine. All right, just to test things as they are now, I'll take the result of this mix node, plug that into the rotation for the rotate instances, and plug that into the geometry so that we actually have something to look at. Then I'll change the start rotation to, let's say, 90 degrees on the z-axis. And so they start out rotated and fall into place. Pretty sweet, but now we just need to mix in that middle rotation. Well, just like we used the rotate rotation node instead of the add node in the randomized node group, we can do that same thing here. We can take this existing rotation and rotate it by just a little bit more in the middle. So I'll drag out and use a rotate rotation. And rotate by that middle rotation. Plug that into the result instead. And now we could multiply these values just like we did before, but just to stick with the rotation socket, because I'm still getting used to it, I'm going to take this mix node, duplicate that down, and when the value is 1 for this middle interpolation, we want to fully use the middle rotation, so I'll plug that into socket B, and socket A I'll leave at 0, 0, 0, so no rotation at all. Then I'll plug the middle interpolation into the factor. And now if we start at 0 for the rotation, we can rotate that by, let's say, 45 degrees in the middle, and then it'll rotate back. What's cool about this setup is that it already works with the anticipation and overshoot. So if we add our anticipation, it'll rotate in the opposite direction just a little bit before rotating down. And with that, we can move on to scale, which is going to use vector sockets again, so we don't have to worry about the rotation sockets anymore. And we can just select this entire location frame and all the nodes in it, and Control-Shift-D, and duplicate that over. Again, I'll cut the geometry connections, Control right-click and drag. And since we already know we need to, I can drag out from this reroute, add in another reroute, and replace this menu switch over here. Okay, but now instead of locations, we want to work with scale, which, as I said before, is a multiplication rather than an addition. Because when the scale is 0, it would be infinitely small, and when the scale is 1, it's going to have no change. So let's cut the inputs from the randomized nodes. Now, a quick note from editing, I'm going to jump into this group node before making it a single user by clicking the number on the right of the data block. And so I'm going to mess up the location randomization node by changing this one into a scale randomization node and still keeping the link between the two. So go ahead and make this a single user before editing it, and then you'll see me correct this mistake later on. Okay, now hit tab to jump into the group node, and we'll just switch this add node to multiply. We can also delete this scale node because we don't want a negative scale in this case. We just want to blend between whatever our maximum scale is and 111. So I'll set the minimum to 111 and Control Tab to jump back out. Then I can plug these vectors into the group input here. I'll call the first one start scale, the second one middle scale, and the last one end scale. Let's make sure all their defaults are 111. And I'll put them into their respective panels. If the defaults are 0, 0, 0, then everything's just going to be scaled to 0, so we definitely don't want that. And even though we set the defaults, we should also change that over here, which again is why I usually change things on the nodes before plugging them in, but I forgot this time. Okay, all the scales are now, and also we can do that with the randomization as well. So I'll cut these connections. And this time I will set them to 111 before plugging them in, and plug them in here at the bottom. Okay, I'll minimize these panels and call this start scale, middle scale, and end scale, and put them in the randomize panel. Oh, and it looks like I forgot to put in the randomize for the rotations. Those are still plugged in as the random values for the locations, so let's cut those connections. And it would be nice if these were displayed in degrees, so let's go ahead and just change these into rotation sockets really quick. I'll change the max to randomize, set the type to rotation, and use a rotation to Euler. Okay, probably not necessary, but just in case. Then I'll hit Control Tab and plug these in as well. As you can see, this node is getting very long, but thanks to the panels, it's still manageable. We got our start rotation, middle rotation, and end rotation. Amazing. Now we have all the effects that I need, and we could stop here if you wanted to. But if we play this back, oh, of course I need to actually plug in the result here. Let's see, I need to take the rotate instances and plug them into a scale instances. Just like so. And just like before, since scaling is a multiplication operation, not an add, we just need to change the vector math node to multiply and plug that into the scale. Things are going absolutely wild, but that's also because we're using this scale, and when the middle interpolation is 0, we're scaling things to 0. Things are popping in and out of existence, which is a very cool effect, but we only want to do that if it's on purpose. So just like we did with the rotation, let's just go ahead and duplicate this mix node, and then only scale by this value when the middle interpolation is 1. But when the middle interpolation is 0, let's set this to 1, 1, 1, and plug that into the multiply, and there we have it. Something still looks off though. It's being randomized a bit, so let's look at our randomized values, make sure that they're all off. And here I'm realizing something that I would have seen if I had plugged in the geometry beforehand, and that's that I messed up the randomized location. I didn't hit the little number to make it a unique instance before editing it to work with scale. So now the randomized location all the way over here has the nodes for scale. So luckily this is an easy fix, but definitely a rookie mistake. So let's go ahead and click that little 6 to make this a single user and call this randomize scale. And let's use that for these nodes as well. Classic, classic. Okay, now for randomize location, really all we needed to do was switch this to add and multiply the maximum by -1 or scale it by -1. Either way is fine. And plug that into the minimum there. Okay, perfect. Now if we play this back, we have our animation. That looks kind of clunky, but our easing is set to none, just to make sure that everything works correctly. But if we set this to in and out, things look a lot better. One thing you might have also noticed, which might have been driving you crazy, is that this effect is happening backwards. We could go ahead and flip this in the factor up here, but the problem with that is that if we add a text object, the ordering of the instances is going to be backwards. And we could flip that when converting the geometry into instances, but I'd really just rather make this a user control because we don't know what type of geometry they're going to be throwing at this modifier. It might not be text, it might be something completely different, and being able to flip it is pretty handy. So let's give a control for flipping the index before it gets plugged into the factor. And since this group input is really long, I'll hit Control H just to hide all of the other inputs and make a new frame for that. And take our input and move this off to the side. Now, we can't actually change the index since that's the one thing about our instances that's set in stone. But what we can change is the ID, which by default is the exact same as the index, but it can be manipulated. So let's use a set ID. I'll drag out from this mesh and just use set ID. And I'll shift right click to create a reroute here and plug this into the reroute. All right, now we can set the ID as the index, just to start out with. And as you can see, if we go all the way to the right of the spreadsheet editor, the ID exactly matches the index. However, we want to flip this on its head, and we used the map range node earlier to do exactly that. So let's drag out from this index and use a map range. I'll plug the result into the ID, and instead of going from 0 to 1, we can go from 1 to 0. Uncheck clamp, then that sort of works, but then we're going to go in the negative direction. So instead of that, let's say specifically to go from 0 to 14 to 14 to 0. For that, again, we have to know how many instances we have, so let's drag out from this mesh, and just like before, let's use a domain size node to calculate the number of instances. We want to go from a range of 0 to 14, so let's use that instance count, and again, subtract 1, because we have 15 instances, but the last index is 14. Let's take one away and plug that into the from max. And then we want to go to a range of 14 to 0, so let's plug that into the to minimum, leave the to max at 0, and now this is flipped on its head. Now I'll take these nodes, and since it could be pretty useful, I'll hit Control G to group them. I'll just call this index to ID flip. Okay, now nothing has changed, but that's because we're still using the index rather than the ID. So let's go into the factor, and where we're using the index all the way here at the beginning, let's go ahead and delete that, and instead just use the ID. Now it plays front to back. I'll hit Control Tab, and let's add one last effect. Often when I'm animating an array of things like this, I want them to pop into existence or disappear at the end. The way that I've sometimes animated things popping into existence is by scaling to 0 or animating it so that it's below the floor and you can't see it, but that causes some real problems when you turn on motion blur, because then you have that one frame of extreme change and it just ruins everything. So what we actually want to do instead is remove the geometry completely if we don't want to see it. So what we want to do is just completely get rid of these instances before they hit 0 in the factor. We can do that all the way at the end, because if we delete things before the location, then it's going to mess up the ordering of the animation, and that's not going to work. So let's just delete everything at the end if it's not in that 0 to 1 range. So I'll take the instances and choose Delete Geometry, switch this from point to instance, and now they're all gone. But what I want to do is only delete the instances whose factor is 0 or below. So I'll go all the way over here. Let's create a reroute just to drag this factor all the way through. I'll create another reroute. And let's search for less than and choose less than 0. But that means that if this is exactly 0, then it still won't work. So let's switch that to less than or equal. Now these nodes pop into existence. But the problem is that we're using this anticipation and going into the negative range before we're actually getting to 0. So what we want to do is use the factor before the anticipation or overshoot. So we can also use that by just going over to our factor here. And for this output result, let's just rename this to final factor. And then let's also output the factor after easing, which I'll call the eased factor. I'll place that above the final factor. And shift right click to create reroutes so it doesn't make it so messy. And let's also output the basic factor here. This one might be useful in shaders and such, so I'll call this basic factor and put that up here at the top. Then I'll hit Control Tab, and we can use these in the output and also over here. So I'll create more reroutes, just like so. This first one's for the basic factor, and then this one's for the eased factor. And actually, why don't I just take the output and plug them in here? This first one is the basic factor. Oh, whoops, that's the input. I meant to take the output, basic factor, and eased factor. Okay, now I can drag this all the way back, create some reroutes, and also plug in this last one here, which is the final factor. Okay, but for this hiding effect, we want to use the eased factor. So I'll take that and plug that in instead. And now that works great. So it gets popped into existence right before it starts moving. We could also do that for the end, just by taking this less than or equal, Control-Shift-D, and choosing greater than or equal, and choosing 1. Then I can plug this into the result, and it disappears right at the end. Now let's give the user control over whether or not this disappears. We'll take a group input, Shift D, Alt P to remove it from the frame. And let's select this for deletion only if the result is greater than or equal, and we have this Boolean checkbox checked. So this and I can plug into the input, and I'll call this hide, and I'll place it in the panel for the end. Then I'll Shift D, duplicate this up. Again, plug that into the group input, call this hide, and place it in the start panel. Now I want it to hide if either of these are true, so we'll use an OR. Boolean math OR. When one or the other is true, then it'll delete the geometry. So right now, neither of these are checked, so they shouldn't be deleted at the beginning or the end. If one of these are true, then it'll just delete that one. And if both of these are true, it'll delete at the beginning and the end. Alright, I know this video is going way longer than my usual YouTube video, but I was just really excited about this effect and wanted to show you every step of the way. There are 2 more optional effects that I'd like to add before we call it a day, but of course you can take this even farther yourself afterwards if you'd like. First is being able to use the factor inside of shaders. Now, since we plugged the factors into the output here, we can go to the end of the modifier down to output attributes and name these attributes so that we can use them in shaders. So I'll take my east factor here and I'll just call this factor just to keep things simple. And we can use this over in our shader editor. So I'll go over to shading, go into top view, and really quickly Shift A, go to input and attribute, just like so. And I'll type in factor. Then if I plug this directly into the surface, just so we can quickly get a preview, well, we're not going to get the result that we're looking for. There are 2 reasons for this. One, we have to realize our instances, because otherwise all of our instances are going to have the same value. And second, we have to capture the attribute on the instances before we convert them back to a mesh. So let's go back to our geometry nodes, and let's look at our shaded result here. And let's take our final result and realize instances. And another note from the editor, I forgot to set material for the text that we created with geometry nodes, and that's the main reason why it's not showing up as anything, but the fixes that I'm just about to talk about are really important as well. Okay, still no dice, but that's because we need to capture the attribute on the instances themselves. Otherwise, if it just looks up the index, it'll think it's the index of the points rather than the index of the instance. So let's go all the way back to the factor over here. Hit tab to jump inside of it, and right before everything gets output, let's go ahead and capture those attributes. So I'll drag out and use a capture attribute, and make sure we're capturing it on the instance domain. Then we also need to plug in our geometry, which we have an input for over here, so I'll just Shift D and duplicate this group input over. Plug the geometry into the geometry here, and plug this captured attribute into the basic factor. And then we also need to have an output for this geometry, such that it's being passed all the way through the node group. So I'll take this and drag it to the top of the outputs. Also, I should drag this one to the top of the inputs, just to keep things consistent. And let's capture all the other attributes as well. So Shift D and duplicate it over. And chain these together. Let's capture that second value, plug that into the eased factor. And lastly, let's capture the one with overshoot and plug that into the final factor. Okay, then everything's going to snap back to 0, and that's because we're no longer passing this geometry all the way through to the location. So let's take our factor group here, and I'll cut this connection, just like so. And now let's pass the geometry through the factor, all the way over to the translate instances. Oh, and the other thing that I was missing here is that I didn't set the material when I created the text. I always forget that you have to do that in geometry nodes. When you create something from scratch, it doesn't have a material index for whatever weird reason. So let's take our fill curves and just set material and set that to our material that we created. Okay, now we have that blend of the factor. And we can use this in our shaders to create all different sorts of cool effects. So just to show you, if I went into the factor and I did not capture these attributes, then what would happen is that the factor would be applied to the index of the vertices rather than the actual instances after we realize those instances, and we'll get an effect like that. So by capturing them here, then we'll get the proper effect. Okay, a couple other options that I want to add is I want to be able to control whether or not I realize the instances. So I'll just add a simple switch really quick. Set this to true, and the other one to false by holding Alt, and output that geometry. Shift D on this group input, plug this into the switch, and let's call this realize instances. And let's make a new panel called geometry, just so we can plug options like this in there, because we'll need to put a couple other things in there as well. But now let's also give the option to flip the animation or not. So let's go all the way back to the front to the flip ID. And let's just create a switch between the normal index and the flipped one. So I'll choose switch, set that to false, this one to true, and set that switch over here. I'll call that flip ID. And then for the input, duplicate that over. This is getting really, really long. Control H to make it a bit smaller. And I'll call this reverse. All right, now very lastly, for everybody who hasn't fallen asleep, let's go ahead and make this work with text objects as well. So I'll hide my cube here and just add a new text object. Hit tab, and I'll call this one motion graphics. Okay, I'll give it a more interesting font. And over in the modifiers, I'll add a new geometry nodes modifier and add our new modifier that we just created. And this one I'll call transform transition. Not a super sexy name, but it's descriptive. Now currently, this just says geometry nodes, not motion graphics, because we're still plugging in the strings to curves. So let's go ahead and get rid of that connection and instead input whatever geometry we hand to the modifier. So I'll take the group input and hit Control H and plug this geometry into the index to ID flip. So now it says the right thing, but it doesn't move at all. And that's because we're inputting meshes rather than instances. Luckily, we now have a new node in 4.1 where we can take different geometry and split them off into instances. So I'll take my mesh and use a split to instances node, just like so. I'll do that for faces, and I'll plug that into the geometry. Now, right now, the group ID is the same for every single face, and so we're just treating this as one instance. So if I set my start position to 2 on the y-axis, and then let's also keyframe a factor here, then it looks like it's still not going to play, and that's because in our factor over here, if we only have one instance and it's 0, then the instance count is 1, we subtract 1, that equals 0, and then we're mapping from a range to a minimum of 0 and a maximum of 0, so there's just no change at all. And then we're also adding 0, so not super helpful. So if the instance count is 1, let's go ahead and use the value directly. And we can just take this subtract node here because 1 minus 1 equals 0, so I'll turn that into a switch node. And we'll use this as the switch. So if it equals 0, then we'll use the false value, which I can plug in the just normal factor value. And then if it's true, then we can use this map range. So I'll create a reroute here, move this over. And now this plays through. So you can see how building the basics of a tool is actually pretty fast, but then working with all of the edge cases is really where all of the work is. Oh, let's make sure we plug this in for the true, and we're good to go. Okay, but now let's split this into multiple instances, and the way that I'll do this is by mesh island. So I'll take this group ID and choose mesh island, island index, and now each individual mesh island is its own instance. As you can see, it gives us the instances in the opposite order as the text node, but we can always control that with the reverse checkbox. All right, now I'd like to be able to stack these modifiers on top of each other. And so if we don't realize instances, we might be plugging in instances rather than meshes. So what I'll do is just separate out the components here by taking the geometry and choose separate components. And so the meshes, I'll use the split to instances for. And if we're working with curves, let's use the spline index. That's an output of the spline parameter node. And let's say if we're working with point clouds and volumes, just to make sure that these are supported, just in case, even though they probably won't be used, but may as well support them anyway. Let's just use the regular index. And then for instances, we don't have to do anything to those at all. So then let's use a join geometry and join all of these back together. Then I'll take all of these nodes, Control G, create a group out of them, and I'll call this convert to instances. All right, this works really well so far, but if we add any rotation or scale, things are going to get pretty weird. Because if we rotate this, let's just do it at the beginning here, along the z-axis, then it's rotating around the wrong point. It's just using the object origin here rather than the middle of each individual letter. And that's because when we split to instances, their origin just stays at the origin. So we're going to hack that a little bit, and I'll do it just for meshes and also not go through all of the options because it just takes way too long. But I'll run through one of them and then show you the final result. So what we want to do is move the origin point for each of these instances over to the middle of the letter. To do that, we need to find the middle of the letter. The fastest way I could think of is to use the bounding box. So if we take our instances here and use a bounding box, then we get a bounding box for each individual instance, and then any mesh operation that we do to each of these instances will happen to all of the instances at the same time. So now that we have this bounding box, let's go ahead and find the very center just by merging everything to the middle. So I'll use a merge by distance, and this is probably super hacky, but I'll just set this to a really big distance, like 1,000,000 or something. Though to be more proper in the final version, I'll probably just average all of the locations of the points. Okay, so now that we've merged everything right to the center, now we have 1 point per instance, and we can sample the location at that point. Since we have the same number of points as instances and all of their indexes match, then we can use a sample index here. And let's sample a vector, and let's sample the position, and let's do that per index. Okay, so this is the middle of all of our instances, and what we need to do to reset the origin for all of our instances is reset their position to 0 and then move them back. So let's use a translate instances node, just like so, and let's move them by this amount. Oh, and we need to realize instances before we sample for the point. So let's realize instances. Otherwise, we're working on the instance domain and not the points domain, and we want a unique value for each of these points. Okay, and now we can move them per each of those points, but it's just moving them in the wrong direction. And let's go ahead and scale this position by -1. So essentially, we've just moved them in the opposite direction and set them all to 0. Now, if we use a split to instance node, even though we're already working with instances, what it's going to do is just reset the position to 0. So here we can see we have the position as all of these numbers, but then when we split to instances by the index, and we need to do this on the instance domain, then that's going to reset all of the positions to 0. Then we can take our translate instances, duplicate this over, and move them back into place. I realize that's a bit overcomplicated, but that did solve a big problem that I had with working with instances, so hopefully you find that helpful. And now, if we look at the final result, this should be rotated in the correct way. Oh, it would also help if we plug this into join geometry. So we're actually passing it through and not through the viewer. And there we go. Now they all rotate around their centers. Just for the sake of time, I'll show you the final version. Also here, where I did the same thing for curves, but then I also gave the user an option to switch between different types of pivot points. So I did the midpoint just the exact same way by merging by distance, but then I also found all of these other different corners by deleting everything except the points that I wanted to find the positions of. One thing that you find is weird though is that when you're working with text, the up value is actually y. And so if you're working with geometry that's not text, it makes sense that the up value is z. And so if you go to geometry and set the midpoint to, let's say, top left, it makes sense that it would be, top as in the z direction, not the y direction. So I also just found all of those for z up as well, and you can switch that up here in the modifier. I also wanted this pivot point to work for instances as well, so I did that same thing. I just converted them to a mesh, found that same midpoint, and then converted them back to instances. That way the behavior is exactly the same, whether it's a mesh object or an instance object. I made sure to preserve the original ID though. That way it works exactly the same whether you input geometry nodes text or a text object. And that's it for this tutorial. I hope you enjoyed it and learned something new. I know it was a little bit longer and more in the weeds than my usual YouTube video, but again, if you want a full introduction to geometry nodes so that you can make projects like this yourself with confidence, then check out the course called Assemble in the description below, and that'll help you get started. Also in the description is the download link for this project, and you can get that for free so that you can use it in whatever you'd like as a modifier. It's super fun to mess with. So if you make something cool with it, I'd love to see it. I'm at John Lampel on Twitter and Instagram. And also, if you want to see more tutorials like this, then like and subscribe. I don't know if people still watch these super long ones, but you did. So thank you so much for watching, and I'll see you in the next one. Bye.